The average treatment effect is a measure used to compare treatments in randomized experiments, evaluation of policy interventions, and medical trials. The 8 measures the difference in mean outcomes between units assigned to the treatment and units assigned to the control. In a randomized trial, the average treatment effect can be estimated from a sample using a comparison in mean outcomes for treated and untreated units. However, the 8 is generally understood as a causal parameter that a researcher desires to know, defined without reference to the study design or estimation procedure. Both observational and experimental study designs may enable one to estimate an 8 in a variety of ways. General definition. Originating from early statistical analysis in the fields of agriculture and medicine, the term treatment is now applied, more generally, to other fields of natural and social science, especially psychology, political science, and economics such as, for example, the evaluation of the impact of public policies. The nature of a treatment or outcome is relatively unimportant in the estimation of the 8, that is to say, calculation of the 8 requires that a treatment be applied to some units and not others, but the nature of that treatment is irrelevant to the definition and estimation of the 8. The expression, treatment effect, refers to the causal effect of a given treatment or intervention on an outcome variable of interest. In the Neyman-Rubin potential outcomes framework of causality, a treatment effect is defined for each individual unit in terms of 2 potential outcomes. Each unit has one outcome that would manifest if the unit were exposed to the treatment and another outcome that would manifest if the unit were exposed to the control. The treatment effect is the difference between these 2 potential outcomes. Random assignment to treatment ensures that units assigned to the treatment and units assigned to the control are identical. Indeed, units in both groups have identical distributions of covariates and potential outcomes. Thus, the average outcome among the treatment units serves as a counterfactual for the average outcome among the control units. The differences between these 2 averages is the 8, which is an estimate of the central tendency of the distribution of unobservable individual-level treatment effects. If a sample is randomly constituted from a population, the 8 from the sample is also an estimate of the population 8. While an experiment ensures, in expectation, that potential outcomes are equivalently distributed in the treatment and control groups. This is not the case in an observational study. In an observational study, units are not assigned to treatment and control randomly, so their assignment to treatment may depend on unobserved or unobservable factors. Observed factors can be statistically controlled, but any estimate of the 8 could be confounded by unobservable factors that influenced which units receive the treatment versus the control. Formal definition. In order to define formally the 8, we define 2 potential outcomes. Is the value of the outcome variable for individual if he is not treated? Is the value of the outcome variable for individual if he is treated? For example, is the health status of the individual if he is not administered the drug under study, and is the health status if he is administered the drug? The treatment effect for individual is given by. In the general case, there is no reason to expect this effect to be constant across individuals. Let denote the expectation operator for any given variable. The average treatment effect is given by, if we could observe for each individual, and among a large representative sample of the population, we could estimate the 8 simply by taking the average value of the sample. The problem is that we cannot observe both and for each individual. For example, in the drug example, we can only observe for individuals who have received the drug and for those who did not receive it. We do not observe for treated individuals and for untreated ones. This fact is the main problem faced by scientists in the evaluation of treatment effects and has triggered a large body of estimation techniques. Estimation. Depending on the data and its underlying circumstances, many methods can be used to estimate the 8. The most common ones are natural experiment and the similar quasi-experiment. difference in differences, or its short version, diff in diffs. The regression discontinuity design method, matching method, methods based on the theory of local IVs. Once a policy change occurs on a population, a regression can be run controlling for the treatment. The resulting equation would be where y is the response variable and measures the effects of the policy change on the population. The difference in differences equation would be where t is the treatment group and c is the control group. In this case, the measures the effects of the treatment on the average outcome and is the average treatment effect. From the diffs in diffs example, we can see the main problems of estimating treatment effects, as we cannot observe the same individual as treated and non-treated at the same time. We have to come up with a measure of counterfactuals to estimate the average treatment effect. An example. Consider an example where all units are unemployed individuals, and some experience a policy intervention, while others do not. The causal effect of interest is the impact a job search monitoring policy has on the length of an unemployment spell. On average, how much shorter would one's unemployment be if they experience the intervention? The 8, in this case, is the difference in expected values of the treatment and control group's length of unemployment. A positive 8, in this example, would suggest that the job policy increased the length of unemployment. A negative 8 would suggest that the job policy decreased the length of unemployment. An 8 estimate equal to 0 would suggest that there was no advantage or disadvantage to providing the treatment in terms of the length of unemployment. Determining whether an 8 estimate is distinguishable from 0 requires statistical inference, because the 8 is an estimate of the average effect of the treatment. A positive or negative 8 does not indicate that any particular individual would benefit or be harmed by the treatment.